about the SPC and how to use your data correctly. And today I'm not going to talk about data registration, but I'm going to talk about data visualization and a specific tool that I have created that have helped so many in so many different industries and has helped different manufacturers to analyze their data and take actionable insights and actually improve their production and reduce their reworks. So let's go to my screen and see more about data visualization and about the specific tool I have created. So as always, this is Andreas Letros, and welcome to my live. This SPC Dashboards is going to eliminate your reworks and non-conformities. So basically, most factories are burning 20 to 100,000 euros per year on non-conformities, scraps, and reworks. And it's true that there are some part of that that you cannot really save, but 40% of that can be solved with proper data analysis. And this data is something I have taken from my clients and the previous company I was working for. And in every area that we were actively doing data analysis, we were saving an average of 40%. Sometimes it was 50%, sometimes it was 30%. But when you apply out of nowhere without any proper when you apply data analysis on a raw area that has never worked before, the average improvement is 40%. So um, and most of them lose the opportunity to save this 40%. Why? Because even though they collect data from the different quality, like the different production steps, that it can be like quality registration, we can be first pass controls, we can be machine data, or it can be automatic measurements. Those data are staying hidden or not properly used, or sometimes they are stored on database but that nobody's looking at, or they're visualized not properly, or even they stay on the paper. But many times those data are stored hidden and not properly used, and that's why they do not get the maximum of this data. What those data should be doing is actually they can prevent reworks, they can help adjust recipes, they can reveal operator performance, they can avoid errors, they can find root cases, they can give feedback to R&D, they can monitor lean projects, and they can even help you with production planning. So those data are very important, and if you don't really use them, you lose a very important opportunity. And that's where the SPC dashboard is going. This is the what the SPC dashboard is doing. The SPC dashboard will take those data and help you reduce your defects by 40% without hiring new people. And it's going to be doing that by giving you actionable insights and taking and helping you take the maximum out of those data. And now I'm going to show you the three common mistakes that people do when they're trying to analyze their data, which is first of all, they analyze what they have from text, Excel, or dot files, which it's the raw material when they use no software to help them. Another thing is when they have no real-time analysis and it's time-consuming, and many people use Minitab for that, especially those quality engineers and quality managers who have black belts and green belts, very sophisticated. And sometimes they have superficial visualizations, which is from QMS systems that they have already paid for. So talking about analyze, this is the most common one. They analyze data from Excel files, CSV files, that file, the raw data, to just scroll the spreadsheets. And that's, of course, that's important. That's interesting when you want to have a micro level analysis of how your machine is working, or you want to have some quick insights. But this way you can now see trends, of course. It's very time consuming because you always have to open your your spreadsheets, and you cannot really find any insights. You can know more or less how your machine is working. You can know more or less how is the parameters, and if you are inside or outside of the tolerances, but you cannot see trends, you cannot see actionable insights, you cannot see which model is performing worst or best, and this way you don't really have the visualization you need. Actually, I have seen some leads that we were talking to, that they wanted to analyze, for example, the temperature of some scenes, and there was the plant manager, and what he was doing, he had that file for every single day, and in order to understand how the machine was working, he was opening the that file, he was converting it every single day on Excel, and then he was scrolling through the data and see if his temperature was inside or outside the tolerance, and how he was going through. And I told him that this procedure is unacceptable for a plant manager to spend so much time on doing that. A plant manager should have a tool that will help him take decisions quickly and understand if his temperature is in or outside the tolerances as quickly as possible. And this is the example of what many plant managers and what many quality managers are doing when they want to analyze their data. The second thing is most common for the black belts and the green belts folks out there, that they have a lot of understanding. They understand very deeply the market, and they use Minitab. And it's true that when you were doing the certifications, they are making you learn Minitab. And I can understand that 5 years ago or 10 years ago, Minitab was the top, was the number one tool to use. But right now, it's a little bit outdated. Why? Because you do a lot of copy paste. It's like every time you want to do an analysis, you have to take the data from the Excel sheet or wherever they are from, and they have to copy them. You have to paste them on the Minitab, and you have to do this analysis. And basically, you have to do every single day you need to do the analysis. You need to do this copy paste thing, which means that maybe the data are produced on Monday, and you give after 3 days the results, which of course is not sustainable, and you are never going to have any savings if you wait 3 days to give the analysis. The analysis should be given at the same day, at the same hour that the data are produced. The second thing is that it's very time consuming to do that, and there are not real insights. What I think about Minitab for myself, of course, who am I to judge, right? But what I have seen is that it's complicated, and it's created to do a very in-depth analysis of, and it's created to help an engineer to see his analysis and his data very deeply, to understand if you're a normal, to have very different graphs, to understand to understand every little detail. But when you do everyday analysis and you want to drive insights, it's, to me, it's not very sufficient. There is no comparison, for example, between models. There is no comparison with shifts. And what I see here, if you see also my screen a little bigger, what I see here is that from this graph, from these graphs, they make sense in theory, but in practice, I don't really see any real value. These graphs don't really tell me right now what I should do on the shop floor. And the most important is complicated. And if I show something like this to operators, they're going to get very confused. Nobody knows how to read them, and they're going to ignore it. From my experience, you need one graph that will tell you all the things you need and go straight to the root causes. Nobody cares about the normal plot. Nobody cares about the different groups. You need to go straight to the root cause, if you like it or not. And that's why I don't like Meetup that much. And the number one reason I don't like Meetup, as I said, is that it takes more time than it should, because there is all this copy paste. And the third thing is something I have seen from the previous company I was working for. We have bought from a QMS system, and we were registering data from the shop floor, and the operators were registering the data from all the steps of the production. And when you wanted to visualize those data, you were ending up with something like this: one graph with 6 million filters. So filter for the position, filter for the machine, filter for the measurement, filter for the operator, filter for the day, filter for, and I'm like, this doesn't give me any real value. I need so much time to set up those filters. It's so complicated, it's so superficial that I don't really get any insights, and I can use it for 1 week. I will lose so much time and I will not really want to use it again. What I want from an SPC dashboard is that I go inside, I choose maybe 1 2 filters, and then I have all the answers I need. I don't really want to search so much for to find my data. And I understand why it happens with quality management systems. The thing is that they have to be generic. They have to fit every single factory. That's why they have all these filters. But in my opinion, no factor is the same. When we create something, it should be flexible, and it has to be adapted to every single factory. We can't do something generalized. But that's what these quality management systems are doing. And it's not wrong, but it's something that I don't like. And if you're doing one of these approaches, what I have seen, even if those approaches are from inside the book and probably they are approved from ISO 9000, or if they are approved from as a Lean Six Sigma, or from your colleagues. From my experience, with these ones you cannot really get the 100%. It will not help you to save non-conformities and to improve your production, no matter how much effort you put in. What I have seen from my experience from different clients working for is this. I created an SPC dashboard that has already template designed to search for the 5 most common root causes as seen on the shop floor. But it's flexible enough to read from any data source you may be having, which is text files, which could be CSV files, would be Excel files, which would be data from the cloud, data from the servers, and it's able to adapt to your production and your preferences. Because if what I've said before is that the reason why Minitab and the reason why um, the QMS systems don't work is that they are created generically for analysis. They are doing this job. They are they are trying to work for every factory. It doesn't work like that. Every single factory for me is different. Every single factory has different needs and a different way to visualize the data. You cannot analyze the data the same for a manufacturing that is analyzing temperature and it creates chemicals, with another one that creates panels, and with another one that probably is analyzing oil. Is completely different. Is a completely different thing. And how does this SPC dashboard actually looks like? I will make my screen a little bit bigger again, and it looks like this. So you may have your data, and then you choose the quote you want to analyze, which in this case is diameters and some dimensions. And on the top, you have a quick summary of how every single quote is working. If it's green, it means that it's in the tolerances. If it's red, it's outside the tolerances, so you can know immediately how to react. Then you have trends, and then you have histograms, and you can see with the trends that there is a period that you were outside of the tolerances, and then this you have to investigate, because maybe there is a shift that is not working well. There is a period, or there is a dependency with time. And of course, you have all the statistics that you need, that are CP, CPK, and percent scrap, standard deviation, and whatever statistics are necessary for your application. Going further, then the number one thing, the one that you find, this is where you find the root causes. And for me, the most important root causes, we will talk about later. The most important root causes is when you have wrong recipes that are outdated sometimes, when the different shifts, the human factor, some operators are working better than the others, and when you have different lines, that one line is working better than the other because you have different settings. Um, and in this visualization right here, you have the box plot that compares the different models, you can compare the different shifts, that compare the different lines, and you have CPCPK analyzed by model. You can have CPCPK for the whole production, ignoring that every single model behaves differently. Every single model have different recipes. And of course, instead of having a box plot, you have histogram comparison. And I think this is one of the visualizations that give the most results when you can compare the different lines, when you can compare the different models with a histogram, because this way you can see if your whole production probably is outside of the limits, or there is only one recipe that's outside of the limits. If there's only one recipe that's outside of the limits, you can fix it quickly. But if your whole production is outside of the limits, then you need to change the machine, for example. And of course, you have CPCPK by model and you have the histogram by model or by line. So you can compare the different lines immediately with just one visualization without so many filters. And of course, I love the X and R chart. I think that there is a space for that. There is a point for that. But to me, they should be done not every single day, but they should be done only on special occasions. And that's why there should be always an XR chart. We should analyze by day, by hour, by week, and understand the differences and the range between the different measurements and the different quotes. And now I would like to go a little bit to the practice, because that's the theory, that's how it works, that's what you should strive for. I provide this to my clients, but I think that everybody should take this one as an example and use it on their own, and try to avoid, for sure, try to avoid um, rigid and not very flexible tools. And right now, I will give you three live situations where the SPC dashboard saved production and achieved the goal, which is the goal to reduce the scraps and the non-conformities and the reworks by 40%. So the number one occasion, I'll make it a little bit bigger. Sorry, I will not show you my face. The number one is when what I told you before, fixing outdated or wrong recipes. And that's the number one thing. If you have 40 models, for example, and you can compare one on top of the on bottom of the other, or one on top of the other, and there is only one model that creates all the problems, that has more scraps, then you focus all your efforts on fixing this model, because maybe it's an outdated recipe, maybe it's a recipe that was created a lot of time ago, or maybe there is a problem with this recipe, or maybe there's a problem with this model. When you can compare in this way the histogram of the different models, you can see, for example, in this picture, that the model B is not working as the other models, is under the tolerances, so probably it's going to create problems, going to create scraps. You don't have to work on model A or model C or any other model. You have to you have to try to align model B with model A. And you can fix this problem in 15 minutes, but you need to have the data. The other thing is the shift. We cannot, when we analyze data, we cannot um, ignore the human factor. One operator maybe is in the company for the years, another operator may be in the company for 1 year, another operator may be like 1 month. We can't really expect them to have the same results, but we want to see their outcomes, we want to see their performance in order to understand if they need training, and if they need to be substituted, or if we need to teach them something about the process. For example, if I have line shift A that is working properly, and I see that I go to shift B and it's not working properly, it's working close to the limits, then I understand that the shift A is working better than the shift B, and thus the shift A should teach the shift B how to work and should transmit their their capacities on the shift B. On the other hand, this is something that I also have seen. You have shift C that doesn't follow the histogram, but is always 1, 2 values. This makes me think that the shift C is not really registering the data, and it's just putting the set value without doing any registration because he doesn't understand the reason for behind doing that, because he's lazy or because he doesn't even know how to measure. And in this case, if you see something like that, it means that this is the most dangerous of all. You know that you cannot really trust the CFC, or you need to train them. You need to go there and understand why this person is not registering data, and if he's missing something, maybe he's missing a measurement system, a caliber, or a micrometer. And that are the three things, mm, and the three possibilities you can have with the shifts, and we can never ignore that. And the third thing is when uh, you have time related patterns, which is mostly about temperatures, flow, chemical parameters, which when you have a nice SPC dashboard that will help you understand your production, you can keep production steady all day long, and that's the example of the temperatures. When you have we're working morning versus afternoon, in the morning you may have lower temperatures, and in the afternoon you have higher temperatures, because your data are affected by the external temperature and the external parameters. On the other side, maybe you want to see the patterns, because you want to understand if after every single if there is any after every single break you have an impact on your production. For example, if after the machine start you start lower and then you adapt slowly, or after the lunch break you start lower and you adapt slowly, or every coffee break you have a disruption of your process. And this is you are able to do that only when you have a properly created SPC dashboard that will help you understand in real time your data, and you don't have just some Excel files that you're just scrolling and losing time on. That are the three things. These are things that are real. These are things that I have applied on different manufacturing areas, from panels, from temperature, from chemicals, oil production, to um, to plastic, to paper production. So these are real things and work in many different industries. So as I said, without data, you're just one more person with an opinion. I will close it here. And thank you so much for participating. Thank you for thank you for your time. I would like everybody to use their data properly. It's a shame to have data and not using them properly, and not visualizing them properly, and losing reworks and scraps for no reason. If you start using your data properly, you can solve many of your problems, and you can reach a 40% reduction on your scraps, especially if you have never used your data before. And I'm confident that everybody can do it. And so, thank you for watching me today, and see you next week with a very fresh and new